Hello all. So now I will be discussing an important problem from the project evaluation review technique or PERT. So here the problem what he has given is the table which indicates the details of the project and the duration is given in terms of days. So activity he has given and the data is also given. We need to calculate the critical path and also we have to draw the network and also we have to determine the expected standard deviation of the completion time. So let us solve this particular method or problem. So I have given different activities. So activity, so given activity 1 to 2, 1 to 3, 1 to 4, 2 to 4, 2 to 5, 3 to 5 and 4 to 5. So A, M, B. So here this one I am considering is optimistic and this one as most likely and this one as pessimistic. So 2, 4, 5, 3, 4, 6, 4, 5, 6, 8, 9, 11, 6, 8, 12, 2, 3, 4, 2, 5, 7. So first what we have to calculate? We have to calculate the expected time for all these activities. So activity 1 to 2, what is the expected time? To calculate the expected time, the formula is A plus 4m plus B by 6. So using this formula for all the activities we will calculate the expected time. So expected time for 1 to 2. So how much? 2 plus 4 into 4 plus 5 by 6, that will be 23 by 6, that is equals to 3.83. For 1 to 3, 3 plus 16 plus 6 by 6, that is equals to 25 by 6, that is equals to 4.17. For 1 to 4, 4 plus 20 plus 6 by 6, that is 30 by 6 is equals to 5. For 2 to 4, 8 plus 36 plus 11 by 6, so that is equals to 55 by 6, that is equals to 9.17. Now 2 to 5, so 2 to 5 activity 6 plus 32 plus 12 by 6, which is equals to 50 by 6, 8.33. So I am directly taking the values. So calculate it. 3 to 5, 2 plus 3 to 5, see 2 plus 3 into 4 is the 12. So directly I am taking like this. 2 plus 12 plus 4 divided by 6, that is 8 by 6, that is equals to 3. 4 to 5, 2 plus 5 into 4, 20 plus 7 divided by 6, 29 by 6, that is equals to 4.83. Now we have to find out the variance. So that variance will be standard deviation square is equals to b minus a by 6 whole square. So 5 minus 2 is, see here, b minus a divided by 6 whole square. So 5 minus 2 is, so 5 minus 2 is 3, 3 divided by 6 whole square. So 3 divided by 6 will be, 3 divided by 6 will be 0.5. 0.5 whole square is equals to 0.25. So for the first activity, so variance is how much? 3 by 6 whole square, that will be 0.25. So variance, here we are calculating the variance. You can continue the calculation of variance in the next line also below this, but as already I have the activities here, expected time here and variance, so that will be easy for me to calculate. So this one also, 6 minus 3 is 3 by 6 whole square, so that will be 0.25, and this will be 2 by 6 whole square will be 0.11, and 3 by 6 whole square again 0.25, 6 by 6 whole square, 6 1, so 1 is 1, 1 into 1 is 1, so 2 by 6 0.11, 5 by 6 0.69. So now we got the variance. After getting the variance, possible paths. So here if we observe the possible paths, let us see the first possible path. So activity 1 to 5, 5 activities are there. So first possible path 1 to 2, 2 to 5. So here 1, 2 to 5. So that is the first possible. Again 1, 2 to 4 and 4 to 5. Second possible path 1 to 2, 2 to 4 and 4 to 5. So here it is the second possible path. Third possible path 1 to 3. So 1 to 3 is there. 1 to 3 is there. So 3 to 5. So 1 is the starting and fifth is the last activity. So but here notes are there. For first activity we have three other activities, 1 to 2, 1 to 3, 1 to 4. Again for second node 2 to 4, 2 to 5 is there, and for individual node is there for 3 to 5 and 4 to 5. So fourth possible path 1 to 4 is there and 4 to 5. So 1 is the starting, 1 to 4 is there. So here 1 to 2, 1 to 2, so 2 4, 2 5. So 1 to 2, 1 to 2, 2 to 5 first path. Second path 1 to 2, 2 to 4, 4 to 5 second path. 1 to 3, 3 to 5 third path. 1 to 4 and 4 to 5. So this is the fourth path. So let us see these paths, the expected time what we got. So possible paths will be, first one 1 to 2, 2 to 5. So 1 to 2, how much? Expected time is 3.83 and 2 to 5 expected time is 8.33. So here 3.83 plus 8.33 will be 12.16. Second path 1 to 2, 2 to 4 and 4 to 5, that will be 3.83 plus 9.17 plus 4.83 will be 17.83. Third 1 to 3 and 3 to 5, 4.17 plus 3 is equals to 7.17. Fourth path 1 to 4 and 4 to 5. So 5 plus 4.83 will be 9.83. So in this one, maximum here we can observe that can be considered as a critical path. So critical path 1, 2, 4, 5 with expected duration, how much we got? 17.83 days. Now in the problem again he has asked, see what he has asked, we need to determine the expected standard deviation of the completion time. So completion time deviation we have to find. See variance, here we have calculated deviation of this is a completion time, expected time to complete. For that we have calculated the variance, and now we have to determine the standard deviation of this particular completion time. So 1 to 2, the critical path what we have identified, 1 to 2, here what we have identified, 1 to 2, 2 to 4, 4 to 5. So 1 to 2 is 0.25, 2 to 4 is 0.25 and 4 to 5 is 0.69. So variance, we will calculate the variance of the critical path. So for 1 to 2 what do we have? 0.25 and 2 to 4 we have 0.25 and 4 to 5 we have 0.69. So standard deviation is equals to 0.25 plus 0.25 plus 0.69. So standard deviation square is equals to 1.1 time. Standard deviation is equals to square root of 1.19, approximately 1.09. Now if we draw the network for this, as I told you, first node is having 2, 3 and 4. For second, see here, for first activity we have other 3 activities which are related with the after the completion of the first activity, 1 to 2, 1 to 3, 2 to 5. Again for second node we have other 2 activities, that is 2 to 4 and 4 to 5. So 2 to 4 and 2 to 5. So 1 to 4 and 1 to 4 and 4 to 5, which can also be considered. Now for 1 to 4, expected time is 5, and 4 to 5 it is 4.83. See, the expected time for 1 to 4 is 5. So here I have taken the 5. The expected time for 4 to 5 is 4.83. In the same way, 3 to 4, so we can connect this, the dot line. So the 3 to 4, between the 3 to 4 it is 4.83, and 9 to 4 it is 9.17, 1 to 2 3.83, and this one 4.17 and 8.33. So in this, how we draw the network diagram, right? Thank you.